Hello guys, I hope my voice is audible to all of you.
Yes.
Okay, so I think last lecture what we started was the concentric shell concept, and I think I told you that okay, I'll be discussing today the grounding part of the concentric shell. Like what happens if we connect one of the shell with ground? That's called grounding or earthing. That's a technical term. So we'll continue with the concentric shell, and I will share the concept of grounding, or you can say earthing. So I told you the last lecture that the Earth is called the infinite charge reservoir. So what is Earth? Infinite charge reservoir. What does it mean? No matter how much charge you give it to the Earth or take it away from the Earth, will not affect its potential, whatever it is. And conventionally, we choose the potential of Earth as zero. So anything which is connected with Earth will also acquire zero potential. So potential of any object connected to the Earth will be 0 volt. Okay. So for example, if I have multiple conductors, let's say 1, 2, 3, and let's say you connect one of them to Earth. So now the moment you connect this to Earth, this will acquire a potential of 0 volt. Okay. Now the moment you connect this with this will also have 0 volt because eventually you connect to the 0 volt. And the moment you connect this with this, again this will be at 0 volt. So anything which is connected to Earth will be at zero potential. And so if you connect something else with that object, will also be at zero potential, and so on. So the two bodies, when you connect two bodies, and if you know the potential of one, the property of metal says that anything which you connect will treat as single body. So now this conducting medium which you establish between this conducting sphere will now convert this three object into one object. So electrically, these are called single object. Physically, you may think it's different, but it's a single object. Why? Because the charge can access any of the surface because this is the conducting path available. And once you ground, it will have the zero potential. So the only rule is when you connect something with ground, the potential will be zero. Now, it should not be taken as if it will have zero charge because it is a very common misconception that a zero potential always refer to zero charge is not correct. Zero potential may lead to zero charge, may not lead to zero charge. So we need to look in the entirety to understand the concept that when we should think, okay, the zero potential will lead to the zero charge and when it will not lead to the zero charge. So it means you may have non-zero charge with zero potential. So we'll see that as an example. I think I can remove this. This is not required. So let me draw the two concentric shell again. And again, remember that this is the most important part of your electrostatics. You can always expect question from this problem. At least in some examination. If not in JEE-Mains, then JEE Advanced. But nowadays there are so many JEE-Mains that someone will get. I will not guarantee who will get, but someone will get for sure. So now there are many slots, multiple sessions happening. So let's say we have two concentric shell with a negligible thickness. Also thickness part we are going to ignore. And why to ignore thickness? So we have to ignore thickness so that when we say it's a spherical shell, it means the inner radius and the outer radius must be taken as same. Although the surface and the outer surface will create two layer of distinct charge or maybe same charge. So let's say this is the radius as A, this is the radius as B. There are two scenarios that we will talk about. So let's say we have given some charge to the two shell. The first is given a charge Q1 and the second is given a charge Q. Sorry guys. So the first step is we assume some charge given to them. Now the moment you give some charge, it will have distribution. And I hope you remember how to distribute the charge. Okay. So the first charge Q1 will spread over the surface.
Yes.
Today I will not draw the lines of force, I'll just draw the charge because that's cumbersome job. And Q2 will spread like this over the surface again in a similar fashion. Because of symmetricity, can we say the spread will be uniform? Yes, we can say.
Yes.
The first step is you simply distribute the charge the way you do. The second step is the inner shell, the lines of force will try to go out. And because you cannot penetrate through the conductor, the lines of force must terminate. And the termination will be possible only when there is a opposite induction of charge. So to terminate all of the lines of force emerging from the Q1, to terminate all, the negative must be equal to minus Q1. Yes or no?
Yes, sir.
The negative must be equal, na? Because you want to terminate everything. And if you remember the lines of force concept which we discussed, that if you have plus Q and minus Q, then it must be equal to terminate all. If it is not equal, it will leave something. If you remember that concept.
Yes.
Now, the second concept that I discussed, that induced charge on any system must be zero. Which means if minus Q1 has induced on the inner surface, by default, how much will be induced on the outer surface?
Plus Q.
Plus Q. This is like unsaid theory, which you must understand. To go one step above, like imagine if I draw one more shell. If I draw outer shell, the outer shell will try to block everything. Now, from the outer surface of the second shell, I mean this shell, the total charge is how much? Can you can you count the charge?
Q1 plus Q2.
And so when the lines of force will emerge from Q1 plus Q2, again it must terminate. So how much we can expect here?
Negative of Q1 plus Q2.
Negative of Q1.
And the outer will have plus of this.
Yeah.
Apart from if something is given also. If I draw one more, the same process will repeat. Then this will have minus of 1, 2, 3, and then plus of the same. Again, if I do, again, if I do, again, if I do, it will keep on happening that way. So that idea will continue for any number of shell. I'll restrict in present discussion to the two shell because we want to understand the concept. Then we can, of course, scale this concept for any number of shell. Okay, so far so good. And now I'll make a switch kind of thing. So it's like a switch. Switch means as per my wish, I can ground, I can unground. So this is like a switch kind of structure. So the moment you close it, the grounding will be established. As of now, it's not closed. Now, the concept of isolated system or isolated shell after the connection, can we say this shell as isolated the shell number 2? Let's say this is 2. So let's say we have two shell, 1 and 2. Once I make the grounding, what will happen to the shell 2? Can we say this as isolated?
Yeah.
Can we say that this is isolated or it is connected to something else?
Connected, right?
It is connected. Now इसके पास माँ है, oh, mother earth, that means grounding. Now who is alone? Which shell?
The inertia.
And second is having grounding. Grounding means a source of infinite love. Oh, that's mother, which means source of infinite charge. Think that way. And you're not alone. You're not alone. So your conservation. Now, can we say that the conservation of charge is a concept which is only true for isolated system? So out of these two shell, which shell will conserve the charge and which will not conserve the charge?
One will conserve.
Very good. So one is having no source connection, like nothing can come or go away from it, or nothing can come towards it because there is no path to achieve the same. So we say that the shell number 1 is isolated, but once you connect the earthing, once you connect the second shell with the ground, the second shell will be grounded, so it is no longer isolated. So this distinction is very, very important for you to understand that when we call isolated, when we call grounding, not isolated. And those who are isolated will follow the conservation principle of charge, of course. And those who are grounded will not follow the conservation principle. So what I'll do is I'll just put this into small snippets like grounded conductor. Grounded conductor will not follow the conservation of charge. So because of simple one reason, the second conductor will have some source. And whenever you have a source, you know what you can do. Now, sometime, I mean, later on, you will see those things that the grounding is done with the help of a battery also. Now, this is 0 volt, but if the battery is V volt, this will become V volt. Now, it is again connected to earth, but with a potential which is not zero to a new value V. So if battery will come into picture, the potential will change to the value that of the battery. I mean, of course, the positive terminal, like how it is connected. If I connect like this, then the answer will be minus. And if nothing is there, it means it is zero. So there are three types of connection possible: 0, plus V, and minus V. That will be like very advanced question that will come across. As of now, again, we'll keep it simple. Let me remove all this thing just for your idea. Don't worry if you're not getting this much. I mean, this is okay. We'll come to that again. So grounded conductor will not follow the conservation of charge, and grounded will have the potential that of the earth, and it will acquire the potential of earth, that is 0 volt by default. Let's say one find a JEE believe that okay, no, this is not correct. So one find a JEE says okay, now assume the earth potential as minus 2 into 10 per power minus 5 volt. Assume it. What is the problem? The moment you connect to earth, it will acquire the potential of earth, which may be any value, need not to be always 0 by default, unless it is not being explicitly mentioned that assume something. You are supposed to assume 0. That is that. But is it always 0? May not. So for all practical purpose, if it is nothing is mentioned about assumption about taking some non-zero value, we are supposed to take 0 value. That's the whole idea. And the other connection will be like grounding with battery. So that is like I will take is a different concept. So grounding with battery means the potential of the battery will be given to the shell instead of 0. Okay. So all these ideas you have to keep in mind that these are possible scenarios that you will come across while solving numericals. Okay. And the isolated will be following the conservation of charge. So isolated conductor will follow the charge conservation. I hope so far so good. Like any doubt in this so far?
No.
Now we'll draw this diagram with some restriction. What are the restrictions now? Should I draw the next page or here we have space? Let me utilize the space. So the moment you ground, whatever charge you might have given or not given doesn't matter, because the final charge will be decided by the ground, not by the charge given to the shell. So the Q2 will have of no use. We'll only draw the Q1. That's how we start. Yeah. So how we start solving question? So we draw the charge only for the isolated one, and we totally ignore the charge given to the. Okay. And the second rule, the facing surface must be equal and opposite. So there is no ambiguity in this. If this is Q1, this is bound to be minus Q1, no matter what has happened to the outer shell. Even though the outer shell is grounded, the minus Q1 will be always there, because that is to stop the lines of force, and that is bound to happen. Therefore, the induction on the inner surface has nothing to do with the grounding, or you can say that process will always occur no matter what you do to the outer shell. Is this clear? And why it is happening? Because we have to stop all the lines of force emanating from the Q1 charge, isn't it? Because the theory says that we cannot pass through conductor. Am I clear?
Yes.
Yes.
Now, what about the outer? Do we have any idea? The answer is no. Your idea will vanish. You have to assume a variable here, which may be 0, which may not be 0. But you will not decide. You will assume. Let's say this is X. So now this is the induction part, which I cannot avoid. Okay. So the minus Q1 is due to plus Q1. So the cause is intact. See, the cause and effect. These two are called cause and effect. I cannot destroy minus Q1 because the cause is still intact, which is plus Q1. So who can destroy this? Only the cause. You cannot destroy effect. You can only destroy the cause. Understood? No, not good.
Yes,
The
got it.
Q1 is creating the minus Q1. So Q minus Q1 is the consequence of Q1. And the consequence and the cause are always related. So until we are not destroying the Q1, I cannot destroy minus Q1 because that is the consequence, that is the effect. That's called language of physics or mathematics also, it's called causality. So in advanced physics, we'll come across this term quite often. The cause is there, effect will be there. If you destroy the cause, effect will vanish automatically. You cannot only work on effect and vanish it. No, because only cause can affect it. The outer, okay, too much philosophy. Let's go to the outer surface. But I said the grounded conductor never follows the conservation of charge. And because they don't follow the conservation of charge, I cannot say what is the charge outer surface. I have no idea because outer surface is not connected with some cause and effect. So outer surface can have any charge, any charge. And because I don't know what I'll do, I'll assume X. And that is where you have to stop. This is the most important part. Now X can be positive, negative, I don't. Or can be 0. What is the rule of grounding? The outer shell must be having potential of 0 volt. Yes or no?
Yes, sir.
Yes.
So your job is write the potential of the outer shell. In terms of every layer of charge and then equate to 0. That's your job. That is how you proceed solving any problem related to grounding. So you will choose any point here because you know the conductor will have the property that the potential of the entire conductor will be same as any point, right? It's going to be same. And therefore, now I need to write net potential of, let's say, this point due to this charge, due to this charge, and due to this charge. How many layer of charge we have? We have 3 layers of charge, and we have to write the answer for all 3, right?
Yes.
Write it down. So I'll start with the inner one. The inner one, the point P is outside. So what is the formula for potential for outside?
KQ by R.
What is R here? How far is the point P from center?
Or B.
Very good. What about the minus Q1? Potential will be minus KQ1 by. See, for any spherical distribution, we we assume the charge to be at its center.
Yeah.
So the point P will be again B.
B.
Now this is a very common mistake. Like they get confused. Okay, is it 0 answer? Is the distance 0? No. For a spherical distribution, the measurement of distance is from center, not from surface, right? So even for minus Q1, the point P is B away. Do you realize this?
Yes, sir.
Yes, sir.
And what is the distance for x?
B.
It is again b. Very good. So kx upon b, and all will be 0. Now this is cancelling, and
X
this
equal
is
to
leading to the answer x is 0. Oh, this is the case. The outer will have no charge. Fair enough. And therefore, now we have the well-defined charge distribution. We know when you ground the outer shell, the charge will only appear between the shell. Outer charge is 0, so no field will exist outside, isn't it? No field will exist outside. So we are done. So what is the distribution of charge? It's very simple. For any situation in which outer shell is grounded, the charge on the outer shell will be always 0. And now this is so, you can say, typical, that one should remember this instead of deriving this long way. Not at all required. I'll give you some heuristic to get the answer without solving it. Common sense. So this is Q1, this is minus Q1. Okay. So minus will appear. Okay. And this is the final distribution, because nothing will appear on the outer surface. Final distribution. How to get the same idea? Through some common sense or some logic. It's pretty simple. If you go to infinity, what is the potential of infinity we take? 0. And what is the potential of the surface? 0. If these two extreme having 0 potential, then can we expect anything in between? Any field?
No.
There should not be any field between, because if it is there, it means some potential difference must be there. So the electric field is the consequence of potential difference that I will discuss very soon. So in the hierarchy of things, charge creates potential and potential difference creates field, and field exert force, force creates acceleration, changes the velocity, and so you get displacement. So this is the world, the simple world. So the fundamental, if you look at the process of fundamental behavior, it is the charge which decides the potential. It is the potential difference which creates the field. It is the field which exerts force, and the force creates acceleration. Of course, it will change the velocity, and so you will have displacement. The entire physics in one line. Because there is no difference of potential, the field must be 0 here. And because I am saying field is 0, then assumption of charge will violate this assumption, isn't it?
Yeah.
The moment you assume some charge, field will occur, which is against the assumption that field should be 0, and therefore we can say that there should not be any charge. Oh. Anyone who got this logic, what I'm saying?
Yes, sir.
Yes.
So the moment I say there is no difference of potential between the two extreme points, nothing should exist between, and therefore that lead to the inference that charge must be 0. Logical way of doing. But of course, it is only for the outer surface. If this logic we apply for the inner surface, it will fail. So we'll see that how. So the step 2 is in between. I'll put some conceptual question also. What is the direction of flow of charge? High to low potential, I mean positive charge. High to low, low to high. How charge flows, guys? High to low, low to high?
High to low.
Of course, charge will flow from high potential to low potential, because
Yes.
the end goal is to equate the potential, isn't it?
Yeah.
And here is the biggest takeaway. That given to shell, I'm not grounding right now, so don't take every question as grounding. So I'm only showing what is given, not what is induced. And also in case of like a ungrounded system of shell, no need to draw the induction part. Induction part is very important the moment you have the grounding because that will change everything. Okay, so now if I ask you what is the potential of the inner surface A and what is the potential of outer surface B? What is VA, guys? VA, tell me. So VA will have contribution from two layers, no? Your layer and the next layer, outer layer. And I'm not drawing the induced. Why? Because this will always come in pair and it will cancel the effect everywhere. So no need to draw this separate. So what is the potential at A?
KQ2 by B.
KQ1 by
AQ1 by
A
A,
A.
plus
That's
KQ
it.
by B.
AQ2 by
B.
B.
very good. What is the potential of the outer shell?
KQ1 plus Q2
KQ1
AQ1?
plus Q2. I mean Q1 plus Q2
Yeah,
by B.
very good.
yes.
Okay, so can you guess which one is at a high potential? Any guess?
VA.
Very good.
The second one.
The inner one is always at high potential.
Okay.
You can see, no? This is B, this is B. So
Yes.
the second term is same, but
Yeah.
this is A, which is small, B is
Ah.
bigger. So this is a big
That
term.
will be big. Yes.
In fact, I will tell you, the inner will always be at high potential compared to the outer for any number of cells. So if I draw multiple cells, maybe 3, 4, 5, 6, 7, 1, 2, 3. Whether you give charge or not, every shell relatively inside will have high potential than every shell relatively outside. Now you may ask why. The answer is simple. The potential of the outer shell is by default potential of its entire volume. Understood?
Yes.
So whatever I have, I will be giving to the everyone inside me. Okay.
Yes.
So whoever is inside will by default will have some value of potential without giving something. Okay. And the inner one will have its own potential, so that will add up. But for inner cell, it will only contribute less than what it is having to the outer shell. So this will contribute less than its surface because you are going away. For a charged shell, the maximum potential is of the surface. Yes or no?
Yeah.
So anyone outside, am I giving full or less?
Less.
Of course, less, because you are going to give you less than your value. So if you have 10, you will give less than 10 to everyone.
Yeah.
And if this is having 20, it will give 20 complete to this. So the outer will get 20 plus less than 10, and inner will get 10 plus 20 full.
Inner. Yeah.
I'm getting the idea what I'm saying.
Yes.
The outer will give everything what it had. Okay, what it has. Okay. The inner will give less than what you have. The inner shell will give always less than what you have because you're going to give to the outer world. No? So you will give less.
Yes.
But the outer will give you full. So the sharing is caring, but the sharing is unequal, right? Okay, I think you're not realizing this. Anyway, you can do it mathematically. If you're not getting it logically. Logically, what I'm saying? The outer will share everything to the inner. But inner is not sharing everything to the outer, isn't it?
Yeah.
And therefore, the net will be less for outer and more for the inner.
Yes, sir.
Okay. So those who are bigger, they give, the elder give everything to the, if elder will have 5 chocolates, they will give you, okay, keep 5. And the kids will not give all their chocolate to the elders, right? It's like, okay, no, no, I will take more. You can take less. Anyway, so VA is going to be more than VB always. And that you should understand without mathematics. Is this clear?
Yes.
So VA is more than VB always. It is always true. And I'm saying this VA is more than VB in context of positive charge. If I make the charge negative, the order will change. Okay.
Yeah.
No, I think order will not change. It will remain same. Yeah, even for negative, it will remain same. It is always same. In fact, this is always true for plus and minus both. So VA is always more than VB. Okay. So now the question is, what happens if you connect a switch between these two cell itself? So the moment I close the switch, what will happen? Can you guess?
The outer shell will gain some potential and
What will be the charge on each cell after the switch is closed? What will happen?
so A will lose some of its potential and B will gain some until they're equal.
So to become equal, what is the criteria?
That
Inside will lose some charge.
Some charge or full all charge? That's the question.
some charge.
Some charge.
But the answer is it will lose everything.
Oh.
Now guess why? Because the outer will anyway share what it is having.
Yeah.
So
Yes.
what I have you will have anyway, right? So if you have anything extra, that will be extra.
Hmm.
So the only way we can the only way they can have equal potential is that you have nothing. See, my potential is your potential. So if you have your own potential, extra potential left there, then net will be more than you, Meena.
Yes.
See, outer will have 10 volts, so inner will have by default 10 volt, whether you have charge or not.
Hmm.
So if you assume some charge further, it will only make it unequal.
Yeah.
So the only way it can be equal is you have nothing.
To lose, huh? Yes.
Because if you have nothing, then anyway I will have same potential than yours.
Yeah.
The other way of thinking is when you connect the two shell with the help of a wire, I have told you something that for any conductor, the charge always resides on its surface. So here the outer surface is the final surface, right? Not the inner.
Yeah.
Ah, correct.
So all of the charge will be only part of the outer surface. It cannot be on the inner surface.
Got it.
Got it.
If you want to do it mathematically, then again you will what you said is okay, that's fine. So you can say it will lose x, it will gain x, that's fine. And then you write the potential. If you equate, x will be q1. Okay, so mathematically, if you want to do, which is not required at all. So what is the potential of the inner surface? K q1 minus x by a due to its own, and then k q2 plus x due to the outer. Okay. Okay, this is the inner potential, the potential of the inner surface. What is the potential of the outer surface?
Q2.
So the inner will contribute this much, and the outer will have its own value. Correct?
Yes.
Isn't it?
Yes.
Yeah.
So A plus B and outer will have okay both. This will cancel. No? So what you're getting here? The Q1 minus x by A equals to Q1 minus x by B. Now this is only possible, and if you want to solve, you can solve. But when this is possible, when this will be equal. See, numerator is same, and we have different denominator.
Q1 will be equal to.
It means the numerator must be 0, because only 0 upon
Yeah.
something is always same, right?
Yeah.
Yeah.
So this means Q1 minus x must be 0. So x must be Q1, which means all of the charge, not few, all of the charge will go to the outer surface. And that is the logic also by the singularity. Now, the moment you connect, it is not two separate shell, it is one shell. And the outer surface will be the outer surface of the system. And by the logic of shell, I mean conductor, every charge can only reside on the outermost surface. Is this clear?
Yes, sir.
So after this example, now we can go to the grounding of inertia. Grounding of inertia. And please do remember this entire concept, because I'm going to use this again in capacitor to find the capacitance. And that time don't tell, okay, say you don't remember this. This is very, very important. So what if I have concentric shell in which inner is grounded? I can do in multiple ways, but I'll draw it here itself. So, okay, I'll make a switch kind of example. Don't worry, there is a small thin hole to which I can put the wire. So again, before the switch is closed, the charge given is, let's say, A and Q1 and Q2. And you know the distribution before things will be closed. The moment you close it, and if you remember that we discussed something that the moment you close it, what will happen? One becomes isolated, but the other will be not isolated. Like one will remain isolated. So the moment I am grounding the inner one, which shell will be isolated?
The outer one will be
After
isolated.
one.
Very good. So outer one is now isolated. And therefore, I have no right to write anything on the inner surface. So I cannot write Q1 because Q1 is not going to be conserved now. So it will have some value which we don't know, because I have no idea what is the value. So what do we do? So when you don't know something, then you assume. So let it call it
X.
X. That's how the math goes. And once it is X, the facing surface will follow the same rule. It is bound to be minus X. And the net induced charge on the outermost surface on a isolated system is 0. So this will have plus X. Understood?
Yeah.
This is the new distribution as per my assumption. I have no idea what is going to happen. Although I can tell you logically what will happen, but let's assume there is no idea. So first I will solve again mathematically, then next I will show you how to think logically. And what is the rule? The inner one is grounded, which means the potential of the inner must be 0. That's the rule.
Yes, sir.
So you will assume some point P as we did earlier. And what will that? Will light potential at this point P due to everyone. And then I will equate to 0. Isn't it? That's the mathematical way of going or approaching the question. So
Yeah.
everyone will do this process and tell me the answer for X. Go ahead. I'm giving you just 2 minutes. That's more than sufficient. While lighting potential, the entire charge on the shell should be assumed at its center. Then think like how to write the formula.
So I got my answer.
Yeah.
X is equal to minus AQ2 by B.
X equals to minus AQ2 by B is the right answer.
Sir, I also got so.
Very good. Anybody else who got this answer?
Sir, I am getting plus.
Oh my God. How?
No. My mistake. Sorry. No, sir, I'm getting minus.
Very good. Those who have got the answer, raise your hand. Just I want to see. Good. Very good. So the potential now, if you look carefully, if the outer cell is positively charged, the induced charge or the net charge on the inner surface of the inner shell will be negative. And vice versa, which is logical. You know why logical? It is logical because whatever outer will have, that will be given to the inner by free of cost. If outer is plus charge, the inner will get how much? Some plus positive potential.
Yeah.
If outer is having positive charge, it will contribute something positive to the entire volume. So the inner shell will get some positive potential free of cost. But grounding rule says it must be having zero potential. So if you are getting positive potential, how to make it zero?
By having
By
equal negative.
acquiring some net negative potential, isn't it? So
Yeah.
the charge is bound to be negative, that we can think, but since we are solving mathematically and our assumption was the positive, so the answer is coming to say that the inner surface will have negative charge, and that negative potential of the inner surface will nullify the contribution of the outer shell. Logical? Fair logical. It's very
Yes.
logical. We can think of, yeah, because I'm getting something positive, so I must be having negative charge. Then only I can nullify, cancel
Yes.
the effect, isn't
Yep.
it? And also, we know that you always contribute less than what you have, right?
Yes.
You always contribute less than what you have. So if you have X value, how much you will have on the outer surface? Okay. Anyway, so you can see we are getting fraction. We are cutting fraction. It is A by B of Q2, which is a fraction, right?
Yeah.
So what we need inside is less than the outer surface charge. That's very logical. And in what fraction? So it's a fraction means A by B is the fraction and the outer charge is Q2. So it's very easy to remember. So the inner will always have a fraction of the outer. And so if I say this is Q and if I say this is R and if I say this is QR, the inner must be having, any guess? Minus.
Minus half Q2. I mean Q.
Correct. That's logical. Very simple. And then I can further do the induction process Q by 2 and Q by 2. So this is the final charge distribution for this scenario, isn't it?
The outermost charge will be Q minus Q by 2, right?
Ah, my bad. Q minus Q.
Yes.
Oh, which is net. Luckily, Q. And what you can understand that as you go from the inner surface to the outer surface, the inner shell to the outer shell, potential will grow from 0 to some positive value, isn't it?
Yeah.
Because the outer surface is having C. The conservational charge also says that the net charge must be conserved. So this is Q by 2 inside and Q by 2 outside. Because net we cannot see, no? Net is still Q. The net remains same, no? Because it is isolated.
Yeah.
And potential will increase. So now what is interesting here, the electric field lines will be like this. But outside is going to like this. So electric field lines will have not just discontinuity, but also a reversal of direction before and after, which is logical because if you go from here to here, potential will increase, then it will decrease. Okay. So they may ask you to draw the lines of force for inner grounding scenario. So you can do it easily, it's not difficult. So let me quickly draw the field lines for this unique scenario. This is very interesting. So if I give this as Q2, so this will I will not draw because this is going to be how much? Minus A Q2 by B. We know this answer, right? Just so now we can do the induction process plus A Q2 by B and then minus so now this is the final charge distribution on every layer of surface. So the minus plus and then the field lines which one should know how to draw. So it is like terminating. And what is most important here is if I ask you how to plot the graph in each case. Okay, so you can see the field lines are very unique. Now, how to draw the graph in such scenario? That's very interesting. So far we have seen the field direction was same. It was readily outward. Now what we are seeing, it is inward and outward. So we take outward as positive and inward as negative. if I draw graph between E versus separation from center, the distance from center. Then, of course, up to A,
Will be 0.
no field will be there. And then we have the field only between uh, A to B and then this. So how to find the field value between 0 to A is 0. So we can say E1 is 0. And how to find E2? By simply applying the Gauss law minus K A Q2 by V upon R square. And what is E3? So it is A Q2. I hope this part is not very difficult to understand.
Yes.
It is clear how to find the value.
Clear.
You can just
Clear.
apply the Gauss law. If you don't know, you can apply it. If you know, you can also. Now you can see clearly the first answer, this is 0, the second answer is negative, this is positive. So accordingly, we have to plot it. The graph is 1 by R square. So how the graph of 1 by R square look like? Something like this.
Yes.
The moment to make it negative, it will reflect on the other side. So x-axis will be the mirror, and the negative graph we always reflect back. That's how we learn how to do the graph. So this graph will appear like this. A reflection. So what we could have drawn in the general cases like this, we have to take the reflection. That's it. Understood? It is clear? Yes or no? Graphical part.
Yes, sir.
And beyond B, we know it is positive. So it will have the logic, the regular graph like this. And nothing will be from 0 to A. This is an interesting graph, right? And you will be asked to find which of the following graph is the correct representation of electric field versus R for the scenario when the inner surface is grounded. This could be a very good question. The graph itself. The other part is anyway bonus. I should have drawn the graph for this also. Yeah, this is very nice graph. So here the graph is only between A and B, right?
Yeah.
And it will decay.
Yeah.
Now one more graph which you should be interested is the potential graph. Let me plot it here one. Separately. So potential, okay, of course, the innermost part, what is the potential here? Is it 0 in the first region or non-zero? So we have only 2 layers and both layer are different separation. So of course the inner will have
Non-zero.
non-zero value with positive contribution is more than the negative contribution. So net will be positive,
Positive.
right? Because the plus Q1 will contribute positive potential.
Yes.
And minus will contribute negative potential, but minus Q1 is far away. So it will contribute less, right? Because it will contribute to same as the surface. Surface is B distance away.
Yeah.
So what is the potential in the region 1? Just in case if I'm interested, what is V1? A
KQ.
Q1 1 by A minus 1 by A. What is V2? By the way, let me write. A Q1 by R, because the inner shell will contribute outer side outside. Outer is still inside, so it is same as surface, right? And what about the V3? It is 0.
0.
Because both, yes, 0.
The outermost surface will
Yeah, let
start from 0, it will go to 0 only. So the graph is very interesting. If I divide it into 3 parts, you can see at A we will have some positive value. So up to A it is constant. So how to do the constant value? Up to A the potential is constant, which is same as what I wrote there, KQ1 1 by A minus 1 by B. And while reaching the B, it must terminate to 0.
Yeah.
So it will be not asymptotic, it will be touching it actually. First curve. Like this. It's clear.
yes.
So graphs are very, very important part, and you must understand how to plot. Okay, I think we should also plot the potential graph here. This will be really interesting. Who will plot it? You can guys try for 2 minutes, and then I'll plot. You can match whether it is matching or not, because that's very interesting graph. Try it out. Try it out. Check your mathematical skill, or especially graphical skill. So do you really understand graph? That will be manifested now. Graph is very natural and logical way to understand mathematics. I mean, calculus can be understood best in terms of graph. And if you're not good with graph, then there is a chapter called area under the curve. You will never get the whole idea how to solve. Graph is very, very important. So Should I draw now? Okay, you can add the value, tell me the value of V1, V2, V3. Like what is V1? So here it is intentional. V1 is, we begin with 0. Because the surface potential of the
Yes,
inner shell
0.
is 0, so anything inside will be 0 for sure.
Yes.
Okay. Now that. Now you have to only think of V2 and V3. So V2 is interesting. The V2 is going to be negative, I think.
Yes, sir. It's negative.
I don't know. Maybe you have to check.
Yes, it will be negative because here it's opposite, right?
So the answer is minus K A Q2 by B by A, which is, and then how much is the outer one? K Q2 by B. It's becoming 0. Just a minute. Oh, my bad. In between will be okay. Just a minute. So V2 will be, this is R plus KQ2 by B. You can say KQ2 common 1 by B minus 1 by R. Anyway, this is negative only because
Yes.
R is less than B. So 1 by R is more than 1 by B. So it is negative number. So I could have written like this with the negative sign outside. And the V3 will be simple. V3 will be in any case.
0.
Y0, Y0, Y0. You have to write for all three layers. Na? So add all charges and add KQ by R,
Yes.
simple. Add all
Okay,
charges. So this will add up to this 0 and this is the net value.
Okay, yes. That's different.
So outermost region, this is the next charge. Na? Just add all charges. Now the next tough job. If you look at the graph, it is 1 by R plus 1 by minus 1 by R plus 1 by. So minus 1 by R will be, the graph will be okay. You
It
start
will be
from
down.
0. So you start from 0. In the region number 2, the potential is net is negative.
Yes.
So up to A it is nothing. 0. And then at A it is negative. Okay. So how the graph will look like? Tell me. Okay, just a minute. It will be as you go away, potential will increase from 0. No? V2 is minus K Q2 B by R. Oh, my bad. Something I have made a mistake. Okay, it will be A by B only. I'm writing in general. So V2 will be how much? I'll add once again. What is V2? So for outer, for the region number 2, we have to take in general point R. And so the potential is minus KQ2 A by B by R plus KQ2 by B, right? So what we're getting here is KQ2 by B, we can take comma, 1 minus A by R, right? I think this is the right way of writing. Yeah. So this term A by R, 1 minus A by R, because R is more than A, so A by R is less than 1, correct?
Yes.
So this entire term is positive. So potential will be positive,
Okay.
net value. As you, of course, that should be the reason, because if you move across against the electric field, the potential will increase. Just like if you move against the waterfall, the height will grow. So if the water is coming down, and if you move against the flow, the height will up. And if you move along the flow, it will go down. Same logic is with the electric field. If you move along the field, potential will drop. If you move against the field, potential will rise. Okay, so it will increase till what value? It will increase till B value. So the graph will be something like this. I mean, how to plot this? Okay, the same method. Okay, those who don't know mathematics, for them, let me show you. 1 by R minus 1 by R, and then you add something constant. So what if I add something positive? It will shift upward. So it may shift like this or like this, depending on
Yes.
how much you add. Okay, so if it is positive, if you are adding something which is making it net positive, it will be above this. Okay. And that is the same thing here. If you break this equation, it is kq2 by b, which is a positive value, minus kq2a by br, which is negative. So it will be like this. So it will grow till b value, and after b, it will decrease.
1 by R.
It's a really nice graph for the potential in this case. It's a very tough graph to understand if you don't know graph. If it is, if you know the graph, it's very easy. So always try to think in that way. Shifting of graph. I hope you have learned something called shifting of graph.
Yeah.
So that is the idea that you have to employ. Okay? So for any function y equals to fx, if you add something here, it will shift in the y-axis. And if you change something here,
It will move right or left.
yeah, so it will move right or left. And if you put a minus sign, it will the reflection about
Mirror
x-axis.
image. Yes.
So it's a reflection. So these are three ideas. If you apply, you can get any graph fairly easy. If you have the even function, then plot for the positive value, the negative will be symmetrical. If it is odd function, it will be symmetrical about the origin. Okay. So even function, if this is the first part, the other part will be like this.
Same. Yes.
If it is odd function, it will be the it is symmetrical about this line. Understood? So it will be like
The opposite quadrant.
something like this. I mean, it will
Skewed.
reflect. It is skewed or something. You can say it is similar. Like it is the reflection about the origin. Actually. So many graph, if you just remember this fashion, it's easy to plot. And how to plot x sin x, e per x sin x. So such graph will come in other chapter, but this is very easy. If you know the sin x graph, x is called coefficient, so it will oscillate between plus of this and minus of this. So plus x, minus x, and then you have to oscillate. And now x sin x is even function or odd function? It is even function.
Even.
And for even function, it is always symmetrical about the. So it will be symmetrical like this. Simple graph. E per x sin x, e per x, e per minus x, and oscillate. Something like this. Not exactly, but something like this. Understood? It will just swing between these two extremes. So graph is very easy. Just spend maybe 1 hour, 2 hour, one fine day. And those who want to see all graph in action, so I might have shared many times, but once again, you can go to
Desmos.
yeah, Desmos or GeoGebra. That's very nice place. And go to GeoGebra and play with graph. Okay. So now we're done with the potential graph, electric field graph, potential values. And of course, these are the values which I have written, not you. So you have to write on your own till you get it right. So go home, practice writing all this and practice all this graph so that you can understand okay what you're doing. So from concentric shell, there are endless questions. We can do one challenging problem, then we can go to the next one. So what I'll do next is I'll bring 3 concentric shell into picture. So let's say we have A, B, C, or you can make it easy by writing R2, R3, or something like that. Now, this shell has given charge density. Okay. What I'll do, I'll just take the exact question instead of solving this randomly. I hope I have shared the electrostatic PDF.
Yes,
Let me search for it.
the sheet, right?
Yeah, the sheet.
Yes.
Everyone is having, or someone has missed. I'll reshare it.
Also, I don't have it.
Okay. Just a minute. Electrostatic. Okay, now I have shared. So come to the page number 64. I'll keep it simple one. A, 2, and 3 as per the question. This is from the advanced level problem. So many doubt will be cleared now. So figure shows a system of 3 concentric metal shells A, B, and C with radii A, 2, and 3 respectively. Shell B is Earth. Okay, B is Earth. Okay. And shell C is given a charge Q. Now if the shell C is connected to shell A, so C and A are connected. So let's say it is not touching the B. So find the charge on. Find charge on. All right. So we will start solving, thinking how to think. Okay, what will be your first step? Like which shell is isolated, which is not isolated? Can you guess?
A
A
and
is isolated.
A
A and
is
C.
no. A is not isolated. B is not isolated. C is not isolated.
Oh,
B is grounded and A and C are connected.
A chair
Yeah.
connect.
it's how connected is.
So they are not isolated. So what is isolated? The A and C together are isolated,
Ha.
Yeah.
which means the net charge on A plus C will be conserved. Understood?
Yes, sir.
Because they are sharing in between them. Na?
Hmm.
So anyway, that charge is not going to ground. So A and C together is conserved. Individually, none is conserved. Anyone getting the idea?
Yes, sir.
A and C are conserved together, not independently. Yes or no?
Yes, sir.
Yes, sir.
B is not conserved because it is grounded for sure.
Hmm.
And charge is given to C,
Yeah.
not to A. So A plus C must be Q.
Yes, sir.
So the total sum of charge on A plus C must be equals to Q. Yes or no?
Yes, sir.
But how much we don't know individually. But what we know is the net should be Q. Do we know independently? No. So we have to assume a lot of variables, isn't it?
Yeah.
So how to start solving question like this? So I'll start with let's say the charge on the outer surface of the innermost shell is X. The facing condition is always same. It is minus X. And because it is grounded, so outer I cannot assume plus X. I have to assume a new value Y. Facing will be always minus Y. And then outermost will be again, I don't know. I can say Z. Because it is again not it is not what to say isolated. So I don't know what is the value. But what I know is the pairwise must be same. That I know. And how many variables we have?
3.
3.
So it means we must have 3 questions to solve.
Yeah.
3 questions. Okay, without solving, I mean, of course, don't solve. Can you guess the 3 possible equations? What should be done? What should be done to get the answer? Can you guess? Anybody?
So firstly, we'll write V equal to
Potential.
0 for B.
Yeah,
Potential
very
should be
good. So
0.
potential of the B must be 0. Yes or no?
Yes.
Yes, sir.
So you know the first equation.
Hmm.
Second is what? That's interesting.
Second will be X plus Z is equal to Q.
X plus Z. Are you sure?
A and C
The
are.
charge on A and C. So what C will have 2 surfaces. No?
Acha, huh.
So Z minus 1.
X minus Y plus Z
Plus Z.
Will be Q.
will be Q. Yeah,
Yes.
very good. So you have cracked the 2 most important equations. The third equation. Think about it. That's the property of conductor. When you connect it 2 or more conductors, they must have what? What they must have? 2 conductors which are connected will have same
Potential.
Potential.
potential. So the potential of A must be same as C.
Yes.
So you got the 3 equations. So God has given you 3 equations and 3 variables. Can you follow your path and get the redemption? I mean solution.
Uh.
Go ahead and solve it. Okay, those who have not understood this entire logic, raise your hand. I'll explain once again. The three pillars of solving. Anyone who is not getting it entirely, like totally miss the idea, like what is happening. All are getting it. That's cool. So here we have three conditions, three equations. You follow the process, answer will come. Don't worry about the answer. And that's why I say no question is difficult. If you know the process, you will get the answer. So this is actually very challenging problem. It was asked in some Olympiad actually, but you can solve with this because you know the process. So do you have the courage to write the question?
Yeah.
Because courage is
Yeah.
very important. So go ahead, guys. I'm giving you 10 minutes to solve. 10 minutes. That is sufficient time. Right? From the Olympiad point of view, 10 minutes is okay. You can write all equation also. Okay. Check. No, answer is not matching. And you're only supposed to find the charge on the B, na? B. So the net charge on the B is, this is the net charge on B, minus x plus y.
So, sir, I got X in terms of Y.
X in terms
But
of y. But
no, but we want answer in Q, right?
Sir, I
yeah,
got all three in terms of Q. I'll just substitute.
yeah. But the answer is
Okay.
minus this.
Okay.
Yes, sir. I also got in terms of Q.
How much?
I got x equals to minus y by 4.
We want
X
in
equals
Q.
to minus y by 4. Okay.
Yes, sir. I also got this equation.
What is the answer? What is the x and y? Okay, so let me write down the equation and see if you can get the answer or not. So the first question I said, okay, the potential of B must be 0. Let's begin with from here. And to write the potential, we have how many terms? We have 1, 2, 3, 4, 5 terms. Oh my God. There are 5 layers. But you can see the X will contribute nothing for B, right? Because KQ by B and the two-way, KX by 2A and minus KX by 2A will 0. So I can clearly see it will contribute nothing. I can see KY by 2A. And I can see minus KY by 3A. And I can see KZ by 3A. Equals to 0, right?
Yeah.
So y by 2 minus y by 3 plus z by 3 equals to 0. So this is y by 6 plus z by 3 equals to 0. So y plus 2z equals to 0. So we can keep it this as equation 1. Let's see if we can get something more. That conservation of charge for A plus C. So for A plus C, x minus y plus z equals to q. X minus y plus z equals to q. Let's keep it like this. In case we need to solve, we'll solve. So this is the question number 2. The third question is VA equals to VC, and I know most of you must have made mistake here. So what is the potential of A? I
So
can
shall I
see,
tell?
yeah.
X by A plus y minus x whole divided by 2A
Very good.
plus z minus y whole divided by 3A,
Very good.
and that will be equal to potential of VC z minus y divided by 3A.
So for C, it is only Z, right?
Oh, yeah.
Because all the pairwise we cancel out.
Yeah. That's where I made my
Only,
mistake.
yeah.
Got it.
I was expecting mistake here only because rest is simple.
Yeah.
Okay, so now can you solve?
Yeah.
I'm giving you 5 more minutes to solve. Everyone, please try this. Just okay, guys, done.
Just a second. So 8q by 11.
Yeah, minus 8 cube 11. I think.
I'll check.
Just check the sign. Yeah, so I think answer is coming.
Yeah, coming.
Minus 8 cube by 11.
Yes, sir.
Fine. So
We need
the,
y minus x, right?
correct, correct.
Yeah.
So the net charge on B is y minus x for sure. So y minus x
Yes,
is
then.
the actually answer. This should be the answer. So now you solve the one of the most challenging problem in the concentric shell. Now we can go to the next concept, which is very, very again equally important. So now the next is called potential due to uniformly charged solid sphere. So whether it is solid sphere or hollow sphere, we know one thing. So let's say the total charge is Q and the charge density you can assume as rho for the timing. And what do we know? That in case of solid sphere, electric field is non-zero even inside, right? So we cannot say E is zero here, as we said earlier, right? Can we say? No. So again, there are two questions that you will be asked. Find the potential when R is less than R, when R is more than R. Okay. So for r more than r, it is very simple because it will act as a point charge and we are enclosing everything. So it is like a point charge. So if you move from infinity, if you take any test charge, and if you move from here to surface, we know the work done formula because the field formula we know. So the electric field, if you know the electric field due to the solid sphere, what is the formula for the E value for less than R inside?
But
And outside it is simple KQ by R square.
2 by r square.
So what you are trying to understand, the domain is having, there are two different domains for the entire region. So we can split the entire space into two domains, you can say. A domain within R and domain beyond R. And that is how the, in mathematics, if you have done integration, we split the limit when the domain changes. So let's say you are trying to integrate a function from a to b, and if you know that between a to b there is a point c at which the function will split into two different functions. So you split the integration from a to c and then c to b, because you know that from a to c we have one function and from c to b we have another function, and then you integrate. The same logic is here. To go from infinity to the surface, we have one kind of field with one different mathematical relation. But to go from surface to within the volume, we have a different field formula. Okay. And therefore, you cannot directly integrate from r, infinity to small r. You cannot do that integration. You must split. So for outer surface, it is easy. Or for any point outside, we have only one domain, right? So if you want to find an answer here, from going from infinity to this point, the domain will remain same, yes or no? Or domain will change? Tell me. If you move from infinity to any point P outside the sphere, the domain will be same or different,
Same.
guys? Domain will be same. And the
Same.
formula will be same, KQ by R square for electric field.
Yes.
So any point, if you R is any point which is beyond the outer surface, we know the answer. It is simply KQ by R, correct? It is as good as a point charge. Yes or no?
Yes.
The major problem is if someone is asking you what is the potential at a distance r inside. So what is the potential r inside? Now this is the difficult part. Why it is difficult? Because the domain will change, so you have to break the integration. So earlier you were writing the answer, but you have to write two separate f dot ds, or f dot dr in two separate ways. So the ext to find the work done dot dr, we have to write in two different domain. One is from infinity to capital R, because that is up to surface is one part, and next will be capital R to small r, isn't it? So this is the basic way. Like, of course, you can do it from this particular fashion. Is this clear?
Yes.
Yes.
We can also do in somewhat. We have multiple ways to solve this question. I'll show you the simplest of all. So for outer, it is clear. KQ bar. Any doubt in this?
No.
Let's say I want to know the answer. Potential at point r distance away from center. Keep it row. I want to know the answer of P, but luckily I know the answer of Q, right? I know the answer of Q. The potential of Q will be how much? Any guess? No guess. No idea. What is the potential of point Q? Tell me, guys. Hello, hello, hello. What is the potential of the surface? This is the Q is the net charge. So what is the VQ? R is the radius, of course.
KQ by R.
Which R is small or capital?
Capital.
Right. So potential of the point Q, which is the outermost surface, is K capital Q by R.
Yes.
And we are only supposed to find the potential of point Q. So the 2 points will have some potential difference. So if I take a test charge from here to here, what is the work done required? So work done will be Q delta V, correct?
Yes.
And work will be F external dot dr. And we have to take it slowly. The best way will be the system definition. Okay. Or as you wish. So, okay, I'll just use this is easier even. You can write EXT equals to Q delta V, or you can write work done by system equals to minus Q delta V. That's the definition. So I hope you have forgotten everything.
Yes.
There are two ways to
No.
solve. Now, we know the electric field inside the volume. Do we know? Yes, we know. And electric field inside the volume will be radially away. Correct?
Yes.
So if you are at any point P or any point R, what is the electric field at any distance? So E at a distance R is rho R by.
3 epsilon.
3 epsilon.
So the force on the test charge will be how much? U into E.
Q into E.
See, I always try to derive using the basic definition of work. So if you're knowing the work, you can get the answer. If you don't know, so try to get it. So now I know the force. So this is the force by the system, because system is applying force outside. Really correct?
Yeah.
And therefore, work done by the system is pretty simple. F internal dot dr, and from where to where? R to capital R, correct?
Yeah.
So R to capital R, what is the an angle between the internal force and the dr? 0. You can see it's acting readily away.
Yes.
Yes.
So can I write Q rho R upon 3 epsilon naught into dr? That's it.
Yeah.
And this is pretty easy to integrate, isn't it? It is a bare integration of R dr
R square by 2.
from R to capital R.
Hmm.
So can we write this as R square minus R square by 2? Yes or no?
Yes, sir.
Yes.
And we know that work done by the system is equals to minus Q delta V. So Q will cancel out, isn't it?
Yeah.
So how much we got delta V by the way?
Rho by 3 epsilon naught small r square minus capital R. Yeah.
Where is it?
Yes.
And delta V means final minus initial. Final we know, initial we don't know. And I can write rho as Q by 4 by 3 pi r cube. Yes or no?
Yes, sir.
Yes.
And 4 pi epsilon naught is k.
Hmm.
So where? Next page or this page? Next page. So what is the next step? Just a moment. So we can write KQ by capital R minus unknown is equals to minus KQ by R cube into R square minus R square by 2. Hmm? Mhm.
Yes.
And therefore, we got the answer VR equals to KQ by R plus KQ by R cube R square minus R square whole by 2. And therefore, I can take KQ by R cube common. In a way, I'm taking LCM. So what I'll get here? R square plus R square by 2 minus R square by 2. Looks nice. So this is KQ by R cube into 3R square minus R square by 2. Yes or no? No. Yes.
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 And therefore, the potential at a distance R will have the answer KQ by 2R cube 3R square minus R square. Now, in JEE-Mains and advanced, this formula was used extensively. In gravitation also, we use it extensively. What will be the gravitational equivalent? Gravitational, which is this is very important because every planet is like a solid sphere, right? So inside the planet, what is the potential? We can write like this. Gravitational equivalent. So every planet is a solid sphere. So if this is a planet, and if you want to know the potential, gravitational potential at a distance r, the VR will be the k we have to replace by g and
G,
charge by
yes.
M.
m. R is the radius of planet and with minus sign because you know it's a attraction. Simple enough or maybe difficult. Okay.
Yeah.
So in gravitation, the formula is very easy. If you know the answer in electrostatics, in gravitation, just switch the symbols and potential because it's attractive. See, every formula in electrostatics we derive with idea of repulsion. And gravitation, everything is attraction. So we have to switch the sign for potential. And that's logical. If you go towards the earth center, you will keep on losing the potential because okay, because they attract. Is this clear? This formula is clear.
Yes.
And
Yes,
now
sir.
you can see what is the potential at the center because that's very interesting. At center, it is 3 by 2 kq by r. So I can say the potential at the center will be 1.5 times potential at the surface. So as you go inside, potential will keep on growing and it will become 1.5 times that of the surface. That's a very easy way to remember. And surface is easy to know. It's kq by r. Similarly, in case of gravitation, it will be minus 1.5 times that of the, possibly 1.5 times that of the surface. Of course, the formula is same. So potential at the center is always 1.5 times potential of the surface. Is this clear?
Yes.
Yes.
There are many applications. There are many applications. And how this equation will look like if you plot the graph between the potential versus R. V versus R. The R will be maximum at where? Where the V will be maximum?
And this is this.
At the center.
No, sorry.
Because you have to work, keep on working till you reach the center, right?
Mm-hmm. Yeah.
So till you reach the center, you're against the field. The field is radially outward throughout the space, beginning from center till infinity. So when you enter the volume, still you are facing the field.
Mm.
So you can keep on working till you reach the center, right?
Yeah.
So potential is maximum at center.
Mm.
And till you reach the surface, it will follow the quadratic behavior as obvious from the equation. So what is the equation? The potential at inside is kq by 2rq, 3r square minus r square. For r less than equals to r, this is true. But for outside, it is a simple hyperbolic nature. So you can see there are shift of formula. We have quadratic behavior, and then we have hyperbolic behavior. Is this clear? And it is a quadratic with minus r square. Can we say it is inverted parabola? This is
Yes.
the inverted parabola, and the maximum is here. So this is like graph will be like this. So it will end here, and without any discontinuity, it will continue like this. So the pink region is the hyperbolic part, and the white is quadrate. Is this clear? And also you have to be very careful in mathematics and physics both. The change of domain is very, very crucial to be read properly. So the domain will have kink or will be a seamless transition, depends on the form. So tell me here what is what we have, is it seamless or there is a kink? A kink means this the abrupt change. So what do you think? The potential is changing drastically at the interface or transiting smoothly. So to understand that concept, you can go back to formula, substitute the value of small r equals to capital R, and check the two equations. Is it giving same answer or different answer?
Same.
Which means it is going to be transition seamless. So
Yes.
if in the option they give you kink, you have to reject that graph. Clear?
Yes, sir.
And if it is abrupt change, if the two formulas are giving different answers, it means there must be a kink. Okay. The other way of thinking is because the electric field is it continuous? The answer is yes, the field is continuous. If the field is continuous, the slope must be same. Because okay, we'll learn later on that E and potential are having a relation. Okay. So you may be asked question like this. Just one example I will give. So in a charged solid sphere of radius capital R, I make a tiny hole. A similar question I can ask from just. Okay. So imagine we have a solid charge sphere and I drill a very tiny hole, very small. Okay. And now let's say we have a charge particle. So generally this question are asked in gravitation, but I'm just trying to create a electrostatic equivalent question. So this is the charge, let's say Q naught. Mass is okay. So we know that if I release from rest, it will accelerate. So while leaving the hole, what will be its velocity? That's the question. And imagine that initially it is at a distance of r by 2. So how to solve this question? So it's again same way you can, if you want to use the energy conservation, that's pretty easy. So using the conservation of mechanical energy, we can write the initial potential plus initial kinetic is final potential plus final kinetic. That's the easy way to solve. And potential of any charge, you can write simply by writing the charge into potential. This is the potential energy, by the way. Sorry. So potential energy we can write as charge into potential of that location. So this is an easy or nice way of writing the answer. So charge is Q naught. What is the initial potential? So we have to use the potential formula if you remember. So we can write as KQ by 2RQ. 3R square minus R square, which is R by 2 whole square. Correct? The initial kinetic is 0. And the funnel is, it's a surface, we can write as KQ by R. And the funnel we can write as half mv square. So I think it is simple enough. Uh, 3 minus 1 by 4, how much? 11 by 4, 11 by 4. R square, am I right?
Yes.
So half mv square. This R square will cancel this and K Q naught by 8 R Oh, 11 by 2. I missed something. Yeah. So you can take common K Q Q naught by R. So generally in gravitation, it is a reverse process. In gravitation, what happens? It is getting attracted inside, right? So you have to impart minimum velocity to reach the surface. They will ask you different question. Find a V must be given just in order to reach the surface. So the same method, and because it will have the negative sign, so everything will be managed accordingly. It is clear.
Yes, sir.
So this will have more question or examples in gravitation, but in electro also they can ask question like this. And if you are inside a sphere, the best way to write potential energy is write the charge of that location into potential due to the entire system. So now based on this idea, let me give you some questions. So we have two rings, and on these two rings we have a charge spread uniformly. So you can see we have okay. So we have two ring, and we can see they are separated by distance x. The plane of the rings are parallel to each other. Okay, just now question is, a test charge q naught is supposed to be taken from this end or this center to this center. So what is the minimum work done required by external agent? Questions clear?
Yes.
Got the answer? So here the simple question is Q naught into delta V. So you are only supposed to write the potential of the final point and the initial point. That's it. So W equals to Q delta V having. See, when you move a single charge across any point in space, what you need to know is only the potential of the final and the initial point. So that will give you the idea that how much work is required. So what is the potential finally? So final potential we have tried for this point, right? So this point will have two contributor. One, the small ring, which is KQ by small r, but other is the bigger ring, which is K capital Q by x square plus r square, right?
R square plus X square, the whole root.
Minus. Initially is how much? The bigger ring self,
AQ by R.
but the small ring will have the contribution how much? KQ by. Is this clear?
Yes.
Yeah.
So I hope this is not difficult at all. Okay.
No. Yes.
Similar question will come like if you have a disk and if you are moving something, what is the work done and so on. So let's say so imagine we have a disk. And sigma is the surface charge density. And we have a minus Q naught charge. Ignore gravity. So if it is released from height h, the minus Q naught and disk will attract each other, correct? Hello,
Yeah.
hello, hello.
Yes.
And if it will attract, so it will accelerate downward.
Yeah.
Yeah.
So while crossing the point O, what will be its velocity? That's your question. So what's your question? Find its velocity while crossing the center of the disk. And it is released from rest. So I'm just putting question in a very raw manner. Released. These all are JEE advanced question asked long time back when it was subjective. So now it's very easy. Earlier it may be difficult. I don't know. So release from rest. Find the velocity, and this is fixed. So find the velocity of charge Q naught while it crosses the center of disk. Now always okay, no need to solve this question. Just write the equation and that's good enough. Okay.
Hello.
Yes.
So the equation, will it be like mgh plus?
MGH? Do
Oh,
not
no, wait.
ignore
Uh,
gravity. Only the electrostatic potential should be written, right? And because I have given the disk with empty, like hollow,
yes.
it means you have to use the superposition theorem to get the potential formula first. So you know the answer for the disk, entire disk. So you write
Yes.
the answer for the big disk minus the potential due to small disk. That will give you the formula. Okay. So your first step should be finding the what?
Potential.
Potential due to the hollow disk at a distance x or h, whatever. Okay.
Yeah.
Yeah. So then think of solving. Okay, just tell me the answer. What is the potential of the annular disk at a height or at a distance h from the axis, from its center? So this will be called annular disk, right? So again, you can also use the principle of superposition for potential as well. And the good thing is potential is scalar quantity. So you just need to subtract the value, not worrying about the direction and all, right?
So it will be sigma by 2 epsilon naught. First, the bigger one, so root of h square plus b square minus b.
Minus B.
Hello.
Formula. What is the
Oh,
formula?
minus h, minus h.
Very good.
And same with the a then.
Yeah.
And
So
minus.
it will be. So H will cancel out, right?
Yes.
So you will get a sigma by 2 epsilon naught. This will be the formula for the potential due to the annular disk. Rest is simple. Conserve the mechanical energy. That's the easy way of writing. So what is the initial energy? Initial potential is how much? Minus Q naught into VH. And the final will be minus Q naught into V H equals to 0. Correct?
Yeah.
So how the equation will look like? So minus Q naught into V initial plus kinetic energy. So minus Q naught into the initial, we got the answer sigma by 2 epsilon naught. See, it is just about writing, how to write it. It is not a difficult task. Now H will be 0 at the center, right? So it is simply B minus A. It will have some kinetic energy half from V square. That's it. So no need to solve, of course. If they will looking for solution, they'll give you some nice value. You can apply and get the answer. And these kind of questions are already asked in electrostatics or gravitation. Okay, similar. So imagine we have the ring of Saturn, right? You must have heard about the ring of Saturn. So the ring of Saturn is like annular disk, roughly we can approximate, isn't it? Hello, hello, hello.
Yes.
So the ring of Saturn is like the hollow, I mean, this annular disk. And let's say if Saturn, just a moment. So let me draw the Saturn ring. So first I will draw the Saturn ring. Okay. So now this is like a Saturn ring. And so I'm taking the inner ring, inner radius as close to surface of the planet, which is R, and outer is, let's say, R plus D. D is the like the width. You can think that way. And now imagine if I wish to write the potential somewhere here. I don't have space, so I'm solving it here. And this is something more than R for sure. Let's call it X. So what is the potential of point P? Let's say if I want to write like this. Imagine this is my ideal Saturn ring, Saturn planet. And you can take the mass of the Saturn as M. And for this, let's say the surface mass density is sigma. And we are trying to get this hypothetical question. Write the potential. So for the entire planet, it is easy to write because it's just like a point mass. So the net potential will be the sum of potential to the planet and the annular disk, isn't it? Hello,
Yeah.
hello, hello. Yeah. So do this. I mean, if you have understood the concept, it's easy. Okay, so I'll write quickly. So the answer will be how much? Minus Gm by X. That's simple formula. The planet will contribute like a point mass because it's outside. And sigma by 2, 4 pi G. Like 1 by epsilon naught is 4 pi G. And the formula is same. It is R plus D whole square plus X square under root minus R square plus X. Done. That's it. Okay, so you just need to convert formulas accordingly. So I'll quickly summarize two more concepts. And that's very, very again important from the point of view of capacitor. That's called the concept of self energy. There is one more thing that's called the potential due to disk at its peripheral point. So let's say if I give you a disk So this won't be asked in any examination, but just if you want to remember the answer, it's good. So there is a formula like what is the potential at the periphery? And this is a very standard question with a standard way of solving. And if you don't know that standard way, it's difficult. But just remember that at the periphery, the potential we can write as sigma r by pi epsilon naught. That's the answer. Okay. Potential at periphery so I'm assuming inform sigma and then that's the answer. Just in case if you come across, which is very rare in case of JEE. So now comes to the concept of self energy. So what is self energy? So it is again a mutual potential energy, but in certain context, we call it self. So what will be the context? So we say that mutual potential energy so mutual potential energy of any continuous charge distribution we call self energy. So let's say if we have two discrete points and I can say this is Q1, this is Q2, and this is R separation, we know the mutual potential is K Q1, Q2 by R. So we need to know the separation and all. But if we have a, let's say a wire, so let's say we have a wire and this wire is given a charge. Now it is impossible to understand what is the gap here, gap here, gap here, gap here. Like it's technically no gap. So theoretically we say there is no gap. It's continuous charge distribution. In reality, of course, there is some gap, but for all practical purpose, we can say it's a continuous charge distribution. So here we cannot define the lambda, the mutual for the individual charge because here the concept of individuality is lost. So although these charges are interacting with each other, but still you cannot call it mutual because it's not distinct charge. It's a charge which is part of one single family. And therefore, instead of calling this as mutual, what we use the word self energy because this is the energy for the entire continuous system. We call it self energy. The self energy can be for the straight wire, it can be for the ring, disc, hollow sphere, solid sphere, or any continuous distribution, cylinder, everything. But out of infinite possible values, only two are the particular case in which we are capable of deriving, or two or three maximum. So the self energy is actually for every continuous charge distribution, need not to be just a sphere or hollow sphere or solid sphere which you study generally. It is for everyone. But we cannot do it mathematically. The problem is mathematics. So we cannot express it in terms of maths, or you can say we don't have sufficient maths to deal with such thing. So wherever mathematically it is feasible, we try to create a formula. And if it is not mathematically feasible, we can understand it will have the self energy, which we cannot express. And that is why you will only come across two formula in JEE syllabus, although we can do three also for the disk also. So let me show you the two formula. So the first what we are going to learn is the self energy of uniformly charged spherical shell. So if we have a spherical shell whose total charge is known to us, just so the total charge is Q. Okay. Now the process is same, like everything we only calculate in terms of work done. Okay. So imagine you wanted to create a charge Q, capital Q over the surface. How this process must have begun in the past? So you brought dq charge and you put over the surface, and you kept on doing this dq, and after a few million years, now let's say the charge is Q at an instant. Assume it. So if you wish to bring the next dq to the surface of shell when the charge is already acquired is Q, what will be the dw? So it's the same definition, the work we define in terms of potential difference in charge, which is you are bringing, right? So potential here is 0, and potential of the surface of a sphere we know how much? Q by R. So how much work is required to bring the dq from infinity to that surface? So work is charge into delta V, which is final minus initial. The same, see, logic remains same. And then we know the answer. This is kq by R. This is 0. So work done, elementary work done in bringing the dq charge from infinity to the point is very simple, kq by R into dq. So what is the total work done in bringing charge up to capital Q? So to put charge capital Q over the surface of the sphere, the work done is kq square by 2R. Simple. Understood?
Yeah.
Now, if this is the work done by external source, it means it will change the potential energy of system.
Yeah.
And delta U means final minus initial. Okay, so final is final, initial is nothing, no charge to 0. So I can say U equals to how much? And this energy we call self. It's just a nomenclature. Self is just a way of saying it. So this is actually the net energy of the system having charge Q over a spherical shell of radius R, or you can say self energy, or you can say total energy of system. Is this clear?
Yes.
You can think about it carefully, how we are defining the work and getting the answer. The next is, I think someone will have lecture right now. Kanu, you have lecture?
Yeah.
Oh. So I'll finish this quickly. The concept of, okay, self energy of of self energy of uniformly charged solid sphere. So here, what are the assumptions that you're trying to create a uniformly charged solid sphere? So what you're trying to keep maintain constant? The volume charge density. So I'm trying to create a sphere with a rho constant. The rho must be same everywhere. So whatever charge I will bring, I'll put in certain way that the rho remains same. I will not affect the rho. And therefore, if you try to establish or create a charge like this, you have to not only bring the charge from infinity, but you have to also put in a certain way to maintain the density. So maybe after some time, okay, anyway. So every time you bring some charge, what you do is you keep on changing the dimension of the charge so that the density remains same. So let's say after a long time, I have already able to create a tiny sphere or a sphere of radius r, maintaining the rho. And the next GQ which I'm bringing, try to understand this concept. The next GQ which I'm bringing, I'll put over this surface uniformly by extending the radius by dr. So when I substitute, I mean, when I put this charge, I'll make sure that I change the dimension to maintain the density. Because if I keep the same radius and if I put charge dq, the density will increase, right? So I'll increase the radius by dr. And now this charge will occupy a thin layer over the surface. So and see the outer this part is not built right now. Only this part is built. So there's nothing like charge present here, right? Are you getting this idea? This part is not present as of now. It's in process of getting built, right? Hello, hello,
Yeah.
hello. So if you put any charge over a surface of a solid sphere, we know the formula. Potential of this surface is how much? It is like a outer surface of the sphere, right?
Yeah.
Right now it's outer surface. So VR will be how much? Don't use the formula of inner, potential inside the solid sphere. It's not inside because the rest part is not built. So it is still the outer surface. Do you realize this?
Yes, sir.
And the answer will be K, the Q enclosed so far upon R. And the potential at infinity is 0. We know this answer. So how much work is required? Same method. The charge you're trying to bring, that's it. Now the problem is here R and Q are function of each other because we know Q is nothing but rho into 4 by 3 pi r cube. And why I'm writing this? Because the rho is the only constant relation known to us in advance. This is the basis by which I'm deriving the formula. So I have to keep this always in mind that rho is constant. So the Q and R must vary in a way to maintain the rho. So this relation is true relation. And therefore you can write dq equals to rho into 4 pi r square dr. and therefore I can substitute everything in terms of R because I cannot keep multiple variables. Or you can convert R into terms of Q. Choice is yours. Okay. So if you want to write R in terms of Q, it will be like cubic equation, right? Which I will not encourage. You can write like this. So dq you can write as rho into 4 pi r square dr k. The q is rho into 4 by 3 pi r cube upon r. So you can see something, k into 4 pi into rho. This is whole square, 4 pi rho, 4 pi rho. Okay. And r cube r square, r power 5 by r is r power 4 dr. I hope this is clear.
Yes, sir.
Yes, sir.
And the rest is
Yeah.
integration. So the external work is how much? K 4 pi rho whole square, and this will grow from 0 to capital R. So r power 5 by
Yep.
this is,
Perfect.
and now you need to convert the rho into the total charge Q. That is how we express eventually. But this is a final answer. This is correct. So the final answer which you will get after substituting the rho will be 3 by 5 kq square by r. Simple. Rho will be, okay, you can count like 4 by 3 pi r cube. You can write as you can multiply by 3 divided by 3, and you can do the manipulation. Okay. I hope this is clear. Hello.
Yes.
Yes, sir. Clear.
Okay, so you can do, okay, I think I have missed something. This is 4 by 3. Yeah, this is 3 I missed. Yeah, everything's fine. So this is the answer we will get. 3 by 5 kq square bar. So this is called the self energy of a solid sphere of radius r, and the total charge q uniformly distributed. If it is non-uniform, the formula will be false. Now, how to compare these two formula? It's pretty simple. So U for hollow, I'll just start quickly. U hollow is how much? KQ square by 2R. And U for solid, what we got? 3 by 5 KQ square by R. This is disturbing, confusing. You may get confused, but there is a simple way. Write as this 0.5 KQ square by R, and this is 0.6. Now this is easy. So 0.5 for the hollow, and for solid it's 0.6. Simple enough. And that's also logical because in solid sphere, the electric field is from where to where? From center till infinity. But for hollow, it is from surface to infinity. So a part is missing. There is no field here, right?
Yes.
So the field is from here till infinity, and here the field is from center to infinity. And what you will learn later on, that the field is the energy. Now that's a big revelation. What you call field is actually energy. It's a manifestation of energy. So wherever in the universe we have field present, the energy is spread, and that's how the potential is actually spread. What you call potential is part of the entire universe, but only that part of universe where field is present. So the part where field is not present is actually devoid of energy. Yes, the biggest revolution of physics. That now you can see the potential energy, not potential, that you can see the potential energy. The potential energy is spread throughout the universe wherever the field is present. So I'll stop this here because someone has to go for the next lecture. And a very small topic is left, that's just for my interest, which I will teach. And then next lecture I'm going to start dipoles. which will be the last topic of electrostatics. And there are few more concepts that I will cover, but I think one lecture, two lecture will be sufficient to finish this entire electrostatics. All right, guys. See you on not on Sunday. I'm trying to figure out like one more lecture. Let me see when. I think Friday. Anyone like how many of you are able to take lecture Friday? Maybe at 9 p.m. Friday 9 p.m. Raise your hand. Let me see how many can take.
Sir, I got disconnected. Could you repeat?
Yeah, can you take lecture on Friday 9 p.m. Friday 9 p.m.
Oh, yeah, sure.
Okay. Kanu cannot take. Huh? You have lecture at night.
Sir, I'm checking.
Manasvi, you have lecture?
Yes, sir.
Okay.
Chemistry.
Ah,
Yeah.
right. Let me see how many are going to miss it.
I can try though. I
Okay,
can-
fine.
yeah.
Great. Tanishi, you have lecture in night?
So I'll be able to attend.
You will be able to, yes or no?
Yes, sir.
Okay. So, okay, all right. So, okay, so done. I think anyway, recording will be there. Don't worry about it. So, Friday 9 p.m. is done. So, we can keep one extra lecture. Okay. So, do remind me actually. Now, this time you have to remind me on Thursday.
Yeah.
Okay. And then Sunday will be there, of course, as usual. Okay. Bye and take care. Good night.
Good night, sir.
Good night, sir.
Good night, sir. Bye, sir.